I'm going to add on to the study I did back in March, labeled Digging Deeper into Geology at Connecticut's Barn Door Hills. Part of that was about the bedrock formed in the Rift Valley, and that bedrock forms the Barn Door Hills. And the other part of that lesson was about kettle holes, kettle hole ponds, and kettle hole bogs. And I'm going to add on to that part of the lesson today. So we'll call this Digging a Little Deeper into Geology with Kames and Kettles. So I'm probably about 90 miles southeast of that location at the Barn Door Hills, and I'm in Washington County, Rhode Island at the Arcadia Management Area. And yes, there's lots of Kames and Kettles here. We're going to be looking at several as the day goes on. And tons of sand deposits in western Rhode Island. This is probably 80-90 feet thick here. We're in the valley of the Wood River, but it was a much larger river when the glaciers were melting. And this area gets some ATV use, which kind of keeps the sand open for me to do this demonstration. So we're going to do a similar demonstration as that day with the ice blocks. Hopefully they'll melt this time. That time it was cool and they didn't really melt to completely demonstrate what I wanted to show. Today is warm and humid. I think they'll melt pretty quickly today. We'll start this with the ice blocks, and then we'll come back in about an hour or two and see if it'll show how Kames and Kettles are formed. We didn't get into Kames that day, but we're going to today. We're going to hike up a Kame. We're going to take my canoe out on a kettle pond and maybe even hike to the bottom of a dry kettle. Okay, I got a couple of blocks of ice here. I was up in Granby at the Barn Door Hills. I used a block of ice this size to demonstrate how kettle holes form. We're going to do that again today. So here's our block of ice that would have been a chunk of the glacier that melted slower than the rest of the glacier, and it was left by itself in a sea of sand like we have here today, but in this case it would be a river of meltwater from that glacier surrounding this sand, or surrounding this chunk of ice with sand. So I'll use my hand to demonstrate how that could happen. It probably buried it, so we'll go ahead and do that. And may have covered it in several feet or more of sand. And when that collapses from the melting, we end up with a kettle hole. Sometimes they fill up with water, sometimes they don't. Now, if you take that idea and turn it around, this looks like a donut, an ice donut. What we have here is a chunk of ice with a hole in the middle. So suppose as the glaciers are melting, we have some ice that's melted and some that hasn't, and there's a hole in the ice that fills with sand. I'm going to fill this hole with sand here. Cover the whole thing here. We're just going to let it melt slowly in the next couple hours here. And that hole that filled with sand, when everything else melts and collapses, we should end up with a fairly round pile of sand shaped almost like an ice cream cone turned upside down. So think of Kame, K-A-M-E, and cone, C-O-N-E, because they're often the same shape. And then the kettle hole should be a round shape once the ice melts and the sand collapses. So we'll give that some time and come back and check on it. In the meantime, there's a hiking trail called the Mount Tom Trail. I've actually explored it in the past. Part of it goes up on a bedrock ridge. I recorded bare oak for my Barking Up the Right Tree channel up there a few years ago. And today we're going to go the other direction on the Mount Tom Trail, up a pile of sand that's labeled on the geology map as a Kame, K-A-M-E. We'll go check it out. It's about 70 feet higher than the Wood River itself. We'll go check it out and see what it looks like. And where I did that experiment with the blocks of ice is just about a quarter-mile west of here on the Mount Tom Trail. And just off the trail in an area that's used by ATVs. The trail crosses the Wood River on this bridge here and enters the woods. The sand that the ATVs were using for their purposes, that sand dune, sand plain, is very, very thick and extends across the Wood River here. And we're walking into the woods, but we're still on that sand deposit. It just has trees on it right here. So you'll get a lot of pine when you're in sand deposits usually. Usually a lot of black oak. Sometimes some white oak too. Here's our Mount Tom trail that we're going to be following right up what's labeled as a K-A-M-E on the surface geology map of this area. So surface geology, it's actually called superficial geology, is a study of anything that's on top of the bedrock. Sand dunes, glacial deposits, places where the bedrock is broken into small pieces called talus, and it's all labeled there on these maps. So it's not too far up this Kame. We're on a flat area right here. We're still below where the Kame is. The Kame's going to show us just how thick this sand deposit is here, because according to the topographic map, it's about 70 feet higher than the river we just crossed. It sure is pretty back here. We've come about 10 minutes from the bridge over the Wood River. We've got a smaller stream flowing into the Wood River. Wood River's just to my right. Wouldn't be able to see it this time of year because of all this clethra, which is an understory shrub that's pretty dense in these acid soils, which are what you often get in sand deposits, is an acid soil. This is our clethra right here. I don't see any in bloom right now, but often it is in bloom this time of year. It gives off a beautiful smell, but it's pretty hard to hike through. So we've been at the same elevation since we crossed the Wood River. Flat, 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 pine needles, easy walking. Not a boulder to be found, not even a cobble on this trail. It's all just sand, as you can see right here. And then all of a sudden we go up. Now, going up is not uncommon in this area. The difference between this hill and a lot of the other hills is this entire hill is made of sand. So as our experiment showed, when you have a depression in the ice that can be filled with sand and does get filled with sand, when the ice melts away, you end up with a hill that's shaped kind of like a cone, steep on both sides often. This one has a little bit of a flat top, but not for long. So we're going up the trail here. The trail isn't going up the steep side of the hill. It's cutting across the hill. Right here off the trail, you can see that the slope is going uphill from right to left, like this, maybe a 30-degree angle. Somebody's dug himself a little burrow here. Again, that proves that this is sand, because most of the hills around here that aren't made out of glacial sands or glacial outwash are tough digging. I don't know if that's from a groundhog or somebody else, but he had easy digging right there. Certainly looks like it could be a groundhog burrow, but I don't ever see groundhogs around here, so I'm not even sure if there are any in these woods around here. I never see them. So here we go back up the Kame. Up, up, up. It's pretty steep on this side when I got off the trail. And it's not that tall, maybe 60, 70 feet higher than the valley of the Wood River. We're at the top. It's kind of a ridge for a distance to the left here, but if we go right or keep going straight, we go right back down the other side of this ice cream cone. So all sand and gravel, and right back down the other side. It goes. We'll follow the Kame and we'll hike it back up it from the other side, and then we'll proceed on to a kettle pond that's showing up on the maps that's supposed to have access for canoes. You know, you don't have to carry your canoe too far. That pond is called Deep Pond, and we'll go check that out and see how deep it really is. Well, a short ride down that one-lane dirt road, we come to Deep Pond fly fishing area. This is labeled as a kettle hole on the superficial geology map. It shows up as a kettle hole in the topographic map because There's what's called depression contours on all four sides. The north side here itself is less of a depression. The sand plane right here is about 20 feet higher than the kettle, the surface of the kettle, or the the water level. This is called Deep Pond. I don't know how deep it is. There's no bathymetric or fishing maps of this that I could find that showed how deep it was. So the fact that there was no fishing map showing how deep this deep pond is, and deep is in the eye of the fisherman, or the geologist in this case, amateur geologist. I got a 35-foot piece of cord with a rock tied on it. We'll see if it's deeper than that. Again, the sand plane is lower on the north side of this, but it's like 50-60 feet high on the south and east and west slopes of this deep pond. So the kettle is much deeper on three sides above the pond and a little lower on this side. But as far as I can tell from the maps, there's no outlet to this pond. It collects rainwater, it collects groundwater, and the water leaves it through evaporation or permeating out through the sand on all sides. Here's Deep Pond. Got the canoe here. It's maybe, I don't know, 4 or 5 acres in size. We'll paddle around it. We'll use our stone and rope and see how deep it is. If we can, I've got knots every 3 feet in that rope. And we'll see if we can get an idea how deep this pond really is and how big that block of ice that occupied this depression really was. Boy, in paddling across this, you sure can see how round it is. So it's not hard to imagine the block of ice filling this depression. We'll get out in the middle, start doing some depth soundings in a few places. Taking about a dozen depth readings here. Crisscross the pond several times. The end where I started, which is the other side of the lake from here, between 9 and 12 feet deep. The south end of this pond, where I'm parked right now, is between 15 and 20 feet deep. And the sand deposits are thicker here. If you go up the hill from the edge of the pond, it gets higher. The sand is higher there. So I think the ice block was probably parked at this end of the depression. And the sand flowed around it. That's what it looks like, at least. We'll do one more here, though, with my primitive depth measuring tool. Well, here's my rock. I got a knot every 3 feet. So there's one knot. 3, 6, 9. Got a bigger knot at 12 feet here. 12 feet. 15. And it's bottoming out at about 18 feet. And I think the best I got was 19 feet. So I'd say, this is just slightly deeper at the south end than the north end, but all of it is at least 9 or 10 feet deep. So, Deep Pond, a glacial kettle hole. Beautiful place. There's no houses around here. It's all pine trees. It smells like pine trees, especially on a day after it finished raining. You almost get an echo here. But the sides of this kettle hole are so close that it doesn't have time to bounce back with any time delay. But that alone tells me that I'm in a kettle hole. The echo. We'll go back and see how our ice blocks are doing. I think they would have melted by now. And there's some dry kettle holes around here I'm going to go check out as well. Well, printed topo maps are kind of hard to find. You can order them from the Geological Society, U.S. Geological Society. I often just keep this downloaded on my tablet and hopefully have service to use it when I'm hiking. U.S. topo maps. And this is going to show the Arcadia Management Area, which is western Rhode Island, right on the border with Connecticut. That dotted line is the border. I'll show you how I found Deep Pond, which I'd never been to before, so I just had to use the map to determine it was a kettle, and how I found what I think are dry kettle holes that we're going to visit in just a few minutes here. So I'm going to zoom in here. If you look at where it says deep pond, there's brown lines around it. Those are your contour lines. In this area, they're 10 feet apart, so each line is 10 feet higher or lower than the one next to it. And the contour line around deep pond, the one that's 130 feet in elevation, is got hatch marks on it. So that means that there's it's a hole in the ground. It's a depression. And that depression is deeper on all three sides here. It's only on this northwest side that it's only 8 or 9 feet above the pond. And then the rest of it's like 50 or 60 feet higher. So that block of ice would have been, you know, somewhere in there, and then sand filled in three sides of it. But it still would have been informed by a block of ice. I can't think of anything else that would have caused that. Just north of there is where that came was. And that's showing 5 or 6 contour lines stacked up on top of each other, kind of shaped like a hot dog there. So I said ice cream cone. Well, you can think of it as an ice cream cone that was rolled out longer than it is wide. And that Mount Tom trail is right there. That little V-shaped trail there is where the trail goes up and over that came. Now, to find the kettle holes that aren't deep pond, I'm going to show you how I did that next. I studied this map and started looking for those depression contours. This basically the symbol for a lightly used road is those two lines parallel to each other. That's a road that's passable by cars and trucks, but not necessarily paved. That's the Blitzkrieg Trail. It goes south from Deep Pond and from the Mount Tom area. And there's a whole bunch of these depression contours right here, folks. One set there. There's another set here. There's some more right here. There's even some more right down here. There was a bunch of blocks of ice that got left behind in that area that's maybe a half-mile wide. And the sand deposits there are 40, 50 feet thick. And there's a whole bunch of holes that are probably about that deep. Now, the depression contours don't guarantee that I'm looking at a kettle hole that was formed by a block of ice. It could be a hole in the ground from a mining operation. It could be a sinkhole, but this is not limestone in this area, so you wouldn't expect a sinkhole here. But I'm going to show you how I proved to myself that it probably was a kettle hole and not a sinkhole or anything else by calling up the surficial geology map of this area. So this surficial geology map is the same size as a USGS topographic quadrangle. It is a topographic quadrangle. It does show the contour lines and depression contours, but overlaid on top of that are color codes of what the surface is made out of, either glacial till, which in this case is showed in pink right here. If I can get it to focus. Not focusing too well, but the pink color is ground moraine, which is glacial till. And the different shades of purple are glacial sands and gravels, glacial outwash. So I'm going to go right back to the area where those depression contours were showing up on the regular topographic map. And I'm going to make sure that that is actually glacial sands and gravels there before I take the time to go in the woods and check it out. So let's find that area here real quick. So I've got the depression contours right off the Blitzkrieg Trail where we're going to go hiking down into and check them out. So it's definitely a purple color there, so I know it's glacial sands and outwash. And you're seeing depression contours. Looks like 3 of them surrounding each other right here. So that would be at least 30 feet deep, maybe a little bit more. And there's several more kettles right next to that. We'll probably just do one because of the time of day. There's another set of them over here and a whole bunch of them down here. This one of those has a swamp in the bottom. You can see that swamp symbol. So all kinds of chunks of ice got stuck in this valley and the sand went around them. Here's Deep Pond. Again, that's surrounded by the same color. So that's how I knew it was a kettle hole. It didn't show, they don't have a symbol for kettle hole on this surface geology map, but they do have it for the Kames. So there's a K right there, that's a Kame. And the one we went up is right there. Now I could tell it was a Kame just by the fact that it was made of sand and gravel and the shape of it, but they actually labeled it as a Kame when they did the geological survey of this area. So let's take a short off-trail hike down into this first kettle hole and see what's at the bottom. So we'll trade the canoe for my hiking shoes and head down and see if we can find a depression made by that ice block that isn't filled with water. Now, it could be swampy at the bottom, but none of the satellite photos seem to show that. It could just be trees, it could be shrubs. We're going to find out real quick. And boy, if I wasn't looking at that map, I would never know this is back here. They've logged right in this area. The pine saplings in the woods are very thick here, so you really can't see that far, even in the wintertime. But if the map proves correct, we should have a kettle hole right back here. And we're just a stone's throw from the road. We go through some thick pine areas with saplings. More open here, a lot of ferns, not so many trees. Yes, I found a depression, but I'll tell you what, you would never know this is back here if you didn't study the map. And if you were just wandering along, you just think it's another hill. It doesn't stand out as a hole in the ground because the vegetation's so thick here. But I believe this doesn't have anything in the bottom except more sand. There is no indication of any wetland plants down there. There's no high bush blueberry. There's none of that clethra that we saw earlier. Or I'll take that back. There is high bush blueberry back here. There's some right here, but there's none growing in a swampy area. It's very common in the swampy areas, but not always in swamps. So we're going down into this kettle hole. It's probably 30, 40 feet deep. Some partridge berry growing here. That's kind of pretty. Plenty of white pine. And right here is like a little natural amphitheater. It's going up on 3 sides at least. So this kettle hole is kind of hot dog shaped. I've reached the bottom. I'm just going to walk down the whole length of it if I can and come back out the other side. So it's longer than it is wide, kind of like the Kame we saw this morning. And obviously it doesn't hold any water because this is all pines down here, and pines don't grow in water, not normally. White pine can grow in swamps, but it's always on hummocks. So if this had water in it, it means it had been extremely wet. And you know, the woods have ears, because I said if it had water in it, it'd be extremely wet. Well, I think there's evidence that it does have water in it, at least for a few days at a time. Because going from normal growth of pine saplings and blueberry bushes, and all of a sudden there's nothing growing right here. I think that if the water table were high enough, maybe in the middle of the winter, this could be a pond, because there's nothing growing here, and there's a reason for that, and probably because it got drowned out. So this is well-drained soil around here. It's sand, it's gravel. This is a kettle hole. It's not a kettle hole pond on the maps. It doesn't show up on the satellite view, but I think for a few weeks a year it probably does have water in it. And because it's a hole, it fills up. If the rate of water coming in is greater than the rate of water draining out the bottom, then you get a kettle hole pond, even if it's just for a few weeks of the year. So here's a kettle hole, off trail. And definitely, this is kind of interesting. It definitely gets water in it. I can see that now. There's even more area right here that shows maybe 10 feet of 10 feet deep area, 10 feet in thickness, where there is no grass and very little plants. So there would be days that this is a kettle hole pond, And then the rest of the time it's just dry, sandy soil with water draining out the bottom. So off-trail kettle hole, pretty cool. They're not too uncommon around here, but again, you would never know this is here if you didn't look at that topographic map and the geology map to determine that. But we've got a little amphitheater here as well. Again, it's probably 30, 40 feet on either side, kind of like that Kame, but in this case, instead of being a raised mound of sand, it's a hole in the sand with a pretty narrow bottom. So imagine that block of ice just sitting right here, melting away and leaving this hole in the ground. So I see a pretty open fern glade on the north side of this kettle. I came in kind of from the southwest corner of it, but it's not that big. We can go up this side and try to find our way back to the road. Just a stone's throw away. And then we're going to go back and check on our ice blocks and wrap up this lesson. But it's been an interesting day. Spotty showers in the area caused me to do a lesson where I wouldn't get too far from my vehicle just in case it got stormy, but it never really did. When I was up on that Kame, it rained for about 10 minutes. I had to stop what I was doing and get back to what I was doing, but it was never a problem. And got more canoe trips planned on better weather days this year. I got at least one more I'd like to try to do on one of the rivers around here. So if I can get the weather for it, I'll do it between now and the 1st of October, maybe mid-October. We'll see how that works out. Okay, we're back at the sand pit here. It's been about 5 hours, so I think that was plenty of time. It's in the mid-70s, it's humid. That should have caused the ice to melt. Let's see what we got here. And on the right, I put a K in the sand so I could find this place again. On the right is where I left that block of ice. And now we have no ice left but our Kettle Hole depression. And as this sand starts to dry, these walls would get less steep. It rained a little while I was gone, so it never had a chance to dry, but it would look more like this in a few days, which isn't much different than it looks right now on a different scale. Now right here is where our donut was, our ice donut. So there wasn't much ice in the middle of the donut. It was mostly just ice around the edge. So here's our Kame right here, sticking up. So this donut was filled, the donut hole was filled with sand, and then the ice surrounded it. And in this case, it would have been a lot more ice around it than I had available to use today. So if we could just take all that extra sand away, this is what the Kame would look like by itself. Amount of sand that had filled in a hole in an ice sheet as it was melting. So they're both are pretty common in this area. And lots of them out on Cape Cod. There's some huge Kettle Hole lakes out there, quite large. They're common in a lot of parts of the country. You know, the legend of Paul Bunyan and his big blue ox comes from the fact that there's 10,000 lakes in Minnesota, and a lot of them are Kettle Hole ponds where the large ox left holes in the sand and they became lakes. That's the legend. So interesting geological formations. That one we saw today with water in it sure was pretty, and I'm sure there's some good fishing down at 15, 20 feet deep. The water stays pretty cool. A lake that small, it may not turn over. So even though it's not that deep, because it's not that wide as well, it may not turn over, and the cold water may stay at the bottom year round for those trout. Didn't bring fishing equipment with me today. I'm more of a hiker than a fisherman, but I have a feeling there's some good fishing to be had there and in the nearby Wood River.